Every online payment looks simple, but behind the scenes, it travels through multiple layers, firewall, load balancers, app servers, proxies, and databases before even a bank notices it. Hello guys, this is Kalpesh. Welcome back to the Let's Crack IT. In this video today, I'm going to demonstrate how 3-tier architecture system works with the bank payment processing. Before we get into actual payment journey, let's look at the architecture from the top. This is a classic Google Cloud 3-tier architecture designed for high-level security, high-scale payment system, and it's broken into 3 major layers. Let's get into that. Presentation layer, that is tier 1. This is the entry point of every request. It includes internet user, WAF, load balancers, web servers. This layer is all about making sure user reaches the system safely, quickly, without letting any malicious traffic enter. Tier 2, which is application layer, this is where the actual business logic lives. Here we have app server, a Squid Proxy for secure outbound calls, and this layer makes decision, validate transactions, and talks to the external payment providers. Then we have a tier 3, which is data layer, and finally the data layer where all the important information is stored and retrieved. This includes Cloud SQL and Redis cache. These layers ensure the consistency, speed, reliability, security of the data. And then you will also see the external components connected to this architecture like payment gateway, fraud check system. These are the essential for authorization and fraud prevention. Now that you have seen the high level design, let's deep into the payment and see how that actually traveling through each of this layer. Let's go over there. This is where the architecture truly comes alive. The journey begins at the moment the customer taps pay now. This single action generates a request containing transaction amount, merchant details, user authentication tokens, device browser metadata, any sessions or card information. This request is like a sealed envelope that needs to travel safely through the system before it reaches anything sensitive. It enters the presentation layer, which is the outer boundary of your architecture. As soon as the request arrives, the web application firewall is the first to inspect it. This firewall doesn't just check the traffic, it actively protects your system from distributed denial of service attacks, SQL injection attempts, cross-site scripting, bot traffic, abnormal request patterns, blacklisted IPs. It's like an airport security checkpoint. If anything looks suspicious, malformed requests, strange payloads, attack signatures, the payment is stopped right there. Only requests that pass all these inspections move to the next stage. Now the clean request reaches the load balancer, which decides where to send it. It evaluates which web server is healthiest, current traffic load, geographic routing, and SSL termination. That is the most important part of it. It spreads the traffic evenly, preventing overload and ensuring high availability. Then we get into the web server, the entry processing unit. The selected web server receives the request, handles initial routing and SSL, and gets it ready for the application layer. At this point, the system still hasn't processed any business logic. The request is simply being prepared and passed forward. Then the request now enters the application layer, where the real intelligence lives. The app server performs all the heavy thinking, including validating the users, checking permissions, verifying if merchant exists, analyzing transaction patterns, running business rules, basic fraud prevention logic, building the final payload to send to the payment gateway. This step determines if the transaction even makes sense before contacting external financial system. Think of it as a central decision maker of entire journey. Then the next step, to communicate with the external system, the request must pass through the Squid Proxy. This is a critical component because it ensures that the outbound calls are secure, internal services stay hidden, only approved domains can be contacted, all gateway communication is logged, caching is applied where possible, and retries happen in case of network hiccups. It acts like a trusted gatekeeper for outgoing requests and ensuring your financial system never directly exposes itself to the internet. Then the next step, once outside your environment, the request hits the payment gateway. This is where the gateway validates the card, token. The next step is the external system, which act as a gateway or fraud engine. Once outside your environment, the request hits the payment gateway. This is where the gateway validates the card and token, check available balance, talks to the issuing bank, evaluate risk scores, sometimes request an OTP or biometric authentication. In parallel, a fraud detection engine may also analyze the transaction for unusual user behavior, high risk location, multiple attempts, blocklisted IPs or devices. This is the point where the transaction is either authorized by the bank or declined. Then the request enters into the tier 3, which is the final tier, where we have Cloud SQL and Redis. Tier 3 is a kind of a data layer, as I explained before. Once the bank responds, your app server writes the results into Cloud SQL. This ensures the transaction is permanently recorded, status is updated, reconciliation can happen later, no double charges occur, long-term logs remain consistent. And then Redis also plays an important role over here for storing session data, rate limits, fraud decision caching, fast lookups to reduce database hits. So Redis keeps your system fast even during the peak hours. Then the next step is response back to the user. Finally, the system constructs a response based on the gateway's authorization, and this response travels back the same way it came, app tier to the web server, to the load balancer, and to the user device. In less than a second, the user sees payment successful or payment declined with a reason like insufficient balance or OTP error or the risk flag. This completes the entire life cycle of the payments. I will be covering the details of how load balancers and ingress and egress proxies works together. Stay tuned. Thank you.